Sources of error. One source of error is due to the limits of the measurement tools. The lowest increment measured by the tool is the limit of its precision. For example, consider the timer. The timer is started and stopped manually, which results in human error when timing the period. To minimize the error, we'll let the timer count for 10 periods and then divide that by 10 to find the period. This will give you the average time for one period in that 10-period cycle. Why would this give you a more accurate time for the period? How could you make it even more accurate? The error introduced by the manual start and stop will be spread out over a greater time, 10 periods, and will have a smaller impact on the correct period. So let's say we have a system that has a period of 10 seconds. And we just measure it once. We do one period to do our measurement. And let's say the error that you introduce by manually starting and stopping it is 1 second. So in this case, your error could be as high as 10% of the measured value. What if we took 10 periods? Okay, 10t. That would be 100 seconds. Your error in measurement is still going to be 1 second. Okay, that's the time it takes you to start and stop, where it's more or less than the actual start and stop time. So you still have that 1 second human error. This time, that's only 1% of the total measurement. So you get a much better result by taking 10 periods. You can actually minimize this even more by timing 20 periods. But then you run into other errors, such as the friction in the spring, which will start increasing the period, and we're not taking that into account. We're ignoring friction again. So the point is, minimizing errors is all about making trade-offs between the friction force in this case and your timing issues here. An assumption that we made when developing our equation for the period of a mass spring system was that it obeyed Hooke's law. Some springs do not have a proportional relationship between force and displacement, and therefore they don't obey Hooke's law. The springs may be old, slightly rusted, or stretched out, so that at one point they may have obeyed Hooke's law, but due to events over time they no longer do. You can check to see if the spring you're using obeys Hooke's law by placing masses on it and measuring the extension to see if there is a linear relationship between the force and the extension, and then it obeys Hooke's law.